Hello everybody, welcome to Saradha Sundaram Academy. Today we are going to see the description of a steam power plant with the reheating and regeneration. What reheating is and what regeneration is. Here the boiler steam drum where saturated steam is produced and the saturated steam is passed through the superheater. Superheater is also part of boiler only. Here the superheated steam cannot be produced in this steam drum because the water is in contact. Half of the drum is having water and on top of you have got steam. So steam you cannot get superheated. So the saturated steam is passed through the superheater and surrounding the superheated tube the flue gas only will pass and it will make the steam superheated. The superheated steam, let us take 1 kilogram is passed. You have got two turbines. One is high pressure turbine and another one is low pressure turbine. The shaft connected to the turbine, you can extract the work from here. So it is first entering 1 kilogram of steam is entering the high pressure turbine, expanded, and it is coming out of the turbine at a lower pressure than the entry pressure. From this exhaust steam, part of steam, that is Y kilogram, is taken to a feed water heater. I will come to this one afterwards about heating. So if 1 Y kilogram is going to feed water heater, what is left over now? 1 minus Y, because 1 kilogram is entering here and Y kilogram leaving here to the feed water heater. So 1 minus Y kilogram is going for reheating, again using the flue gas only. This 1 minus Y kilogram of steam is heated. Heated to how much temperature? It is heated to the same temperature at which this 1 kilogram was entering into this high pressure turbine. Temperature is same but at a lower pressure because already expansion has taken place here. At a lower pressure this is going, but at the temperature at which this 1 kilogram was entering. The reheating is done to the same point. Okay, so here 1 minus Y kilogram is entering and the expansion takes place. Somewhere in between, steam, Z kilogram of steam is bled. This process is called bleeding, extracting little bit of steam from the turbine casing at different stages for heating the feed water. That is called bleeding. The steam that is extracted is called blood steam. So that is only little bit, that is Z kilogram. After the final expansion in the LP turbine, low pressure turbine, so how much steam will come out? Already 1 minus Y is entering, Z kilogram is extracted, so the leftover will be 1 minus Y minus Z kilogram. That is coming out. That is the exhaust steam which is coming out of the LP turbine. That is condensed. After condensation, that is extracted by the feed pump. This condensate is heated here. That is why they are called feed water heaters. Here in this diagram, I have shown you two types of feed water heater. One is called open feed water heater and another one is called closed feed water heater. The purpose of heating the feed water, I will get into that later. So what is open feed water heating? Nothing but this condensate will be mixed up with this steam which is bled for heating it. This naturally this temperature will be less, this temperature will be more, this pressure also will be less here, but this pressure will be more. So the feed pump is required and both are getting mixed up here. So the steam loses the heat and gives it to the feed water. The temperature rises and that feed water is passed through the tubes of the closed feed water heater. The difference between open feed water heater and closed feed water heater is that here the steam which is bled as well as the condensate getting mixed up. Here it will not mix up. It is similar to a shell and a tube type of heat exchanger wherein the feed water passes through the tubes, surrounding the tubes in the shell, the steam which is bled, this 5 kilogram, it is heating the feed water which is passed through the tubes. So this steam which is used for heating this feed water which is going through the tube, that will get condensed and afterwards through a steam trap, the steam, the condensate is getting mixed up again with this steam as well as this one. So naturally, how much here you will get? Here 1 kilogram, because it is 1 minus y minus z is coming here, z is coming here and y is going here. So the net result will be 1 kilogram of feed water through the tubes passed into the boiler steam drum. So these are the components of a steam plant where feed water heating is done. This feed water heating is called as regeneration, and also reheating is done between HP turbine and LP turbine. What are the advantages of this reheating? Why do we extract steam? This exhaust we are heating up and bringing up the temperature to the same temperature as at the inlet of the HP turbine. Why do we do the reheating? For that, if we look into this TS diagram, we will understand better. The TS diagram. So this HP turbine inlet is 0.7 and the exhaust is 8. So 7 to 8 is the expansion which takes place in HP turbine. Okay, 7 to 8. Afterwards, at a lower pressure, At a lower pressure, we are adding heat. Where are we adding heat? You see, this is the point 8 to 9. We are adding heat at a lower pressure than this pressure. This is a lower pressure. But we bring the temperature of this to point number 9, that is 7, and T7 and T9 are equal. And then expansion is done, isentropic expansion from 9 to 11. Can you see, from 9 to 11 the expansion takes place. If we don't have this system of reheating, if we allow the steam to expand from this pressure to this pressure in only one turbine, what will happen? This, can you see this? From here, the steam would have expanded to this point. Okay. So what is the work done in this case? It is H7 minus H11 dash. Let us take this one, H11 dash. Because we are doing the reheating, now what is the work done? In the first turbine, that is HP turbine, this is the work done. H7 minus H8. And one more turbine, LP turbine, what is the expansion? From here to here. So that is H9 minus H11. So this plus this is the work done. In case we have got HP turbine and LP turbine, and in between we are doing the reheating. So work done increases. Then the thermal efficiency also increases. You know, the temperature increases. This temperature rise is achieved by the heat of flue gas, which would otherwise go waste into the atmosphere. By increasing the pressure and temperature, we know Rankine cycle efficiency will increase. In this case, we are increasing the temperature back to 0.9, so thereby the thermal efficiency increases. Third thing, in case if we had expanded from H7 straight away to this is the condenser pressure. This is the condenser pressure. If we straight away expand to condenser pressure, so this is the point at which the steam will be coming out of the turbine. What is the condition of the steam here compared to this one? The dryness fraction of this point is less than the dryness fraction of this point. That means moisture content of the steam will be more. When the moisture content increases, what happens? Erosion increases. So by reheating, we are able to increase the dryness fraction of the steam which is exhausted out of the turbine. Thereby, the moisture content is reduced. Erosion of the blade is decreased. This is another advantage of reheating. And one more advantage is there. By reheating, the specific steam consumption reduces. Specific steam consumption means how much steam is required to produce unit power. So by reheating it, we are able to produce more power, the same amount of steam. So specific steam consumption decreases. When it decreases, what happens? The amount of water required in the condenser also decreases. There is another advantage. Okay. So the advantages I will repeat again. By reheating it, work done increases, thermal efficiency increases, erosion of the blade decreases, because the dryness fraction increases. Wet steam causes more erosion, and wet steam causes more internal losses. So the dry steam, that is, the internal losses will be less, the blade efficiency will improve, and specific steam consumption, as I mentioned, decreases, which decreases the amount of water required in the condenser. Okay, these are all the advantages of reheating. That is why you have got an HP turbine and LP turbine. In between, the steam is passed through the reheater. This is the reheater, and it is passed back to the LP turbine. Okay, what is regeneration? Regeneration is nothing but small amount of steam is extracted at different stages, like here 1 y kg of steam is extracted, here z kg of steam is extracted for increasing the feed water temperature. Before the feed water enters into the boiler, we want to increase the temperature. Why we want to increase the temperature? So if we increase the temperature of the feed water here entering into the boiler, one thing is the heat added in the boiler will be at a higher temperature. And that higher temperature, due to that higher temperature, thermodynamic efficiency increases, because we talk about Carnot cycle, wherein the heat is added at a constant very high temperature. We say the Carnot efficiency is the maximum, whereas in the Rankine cycle, the average temperature at which the heat is added is reduced. That's why the Rankine cycle efficiency is always less than the Carnot cycle efficiency. By increasing the temperature of the feed water entering into the boiler, the temperature at which the heat added is increased, thereby it increases the thermodynamic efficiency. Another advantage of regeneration or feed water heating is we are able to supply the feed water at a higher temperature into the boiler, which reduces the thermal shock in the boiler. Just imagine boiler is at a higher temperature, and if we are supplying this feed water at a lower temperature, at low temperature suddenly the water entering, the thermal shock, which can be avoided if you are able to supply the feed water at higher temperature. This is another advantage of regeneration. But one small disadvantage is the power developed will little bit reduce, because you know that here 1 kilogram is entering, 1 kilogram is coming out, but into the next turbine it is only 1 minus y kilogram of steam is entering. So this y kilogram of steam which is extracted for heating, that will not do any useful work in between 9 and 10 or 9 and 11 in case of this turbine. At the same time, you see there's another z kilogram of steam is extracted here for heating. So again little bit of steam is reduced in this section, in these stages. So little bit of power developed will be reduced. There's a disadvantage of this one. So this steam, which is, as I explained already, we have got two types. One is the open feed water heater and another one is the closed feed water heater. In a steam power plant, you will find both are used. Here only two shown, one closed and one open. Generally you will find in a bigger plant you can have even 6-7 feed water heaters, out of which at least one feed water heater will be open. The other feed waters heaters will be closed. Why that one open feed water heater is used or necessary? It acts as a deaerating the steam. So generally hot water can hold less gas than cold water. Here even though we have shown this open feed water heater at a lower pressure than this one, because this y kilogram which is extracted is at a higher pressure than this z kilogram of steam which is extracted. This is at a lower pressure. It is preferable to put this open feed water heater in the high pressure side, because at high pressure side where the high temperature is maintained, it will hold less gas, so deaerating will be better when the open feed water heater is used at a higher pressure range. But one disadvantage with the open feed water heater will be, for each feed water heater one pump, a separate pump is required. In case of closed feed water heater, one feed pump can supply even 3-4 feed water heaters, because here the feed water is not mixing with the steam. So that's one advantage of this one. But at least one feed water open heater will be there in a steam plant, as I said already, for deaerating the steam. So that how it is represented in this regeneration is represented in a TS diagram that we will see here. Mentioned already, 7 to 8 is turbine expansion, HP turbine expansion, steam expansion, out of which y kilogram of steam is extracted for heating the feed water. That is this one. Okay. So from here to here, this is a closed one. So 8 to 12. So 8 to 12, it loses the steam loses the heat. It loses the heat to the feed water which is going through the tubes from. So this temperature of feed water increases from T4 to T5. That is this. Okay. So 8 to 12, steam loses the heat. So that lost heat is used for heating the feed water from 4 to 5. And then this 12 to 13, through a steam trap, this is coming and getting mixed with the steam and this condensate which is coming from here. They're all getting mixed. At the same time, 13 also is getting mixed. Can you see here? So 8 to 9 is, it is reheating done here. 9 to 10, it is expansion. And at 10, it is Z kilogram of steam is used for heating the feed water temperature from T2 to T3. So 2 to 3, the temperature is increased by this steam. Afterwards, it is this and this getting mixed up because it is an open feed water heater. And from 10 to 11, see already 1 minus Y kilogram entered here, Z kilogram gone here. So 10 to 11 is 1 minus Y minus Z kilogram expansion in some more stages, and it's coming out. This is a condenser. And from 1 to 2, it is the feed pump increases the pressure, and this is a constant pressure line. Again at 3, you have got one more pumping. The pressure increases from 3 to 4, and 4 to 5 the temperature increases here in the feed water heating, and 5 to 6 is the temperature increases in a boiler steam drum, and in the superheater it is the temperature increases at constant pressure. So this is how the TS diagram has to be represented. Okay. So if you have got any doubt, you can write. Nothing else. I hope you understood this. Thank you.